So far, 12 students have responded. Remaining, please attempt the quiz. Remaining students, attempt the quiz. Just 2 minutes are remaining. Hurry up, students. Okay, fine. I'm stopping the quiz now. Okay, students. So we'll discuss about this quiz for a few minutes and then proceed towards the next part of the course. So I received the responses from your side. 18 students responded. So responses are recorded. And the analysis is done by the Microsoft Teams software, and we get a result in Excel sheet. That Excel sheet results I am sharing with you. So these are the results. Are the results are visible to you? Are you able to see this Excel sheet? Somebody please reply.
Yes, sir.
Okay. So you can see here your name and the points that you got in the quiz. So out of 10, Rahul Shinde, Pradeep Bhatkar, Harish Bikankar, Vaishnavi, Yogi Raj, and Sanket have got 10 out of 10. Congratulations, very good. And remaining student, I think you get confused between the second question. That is, let's come back to the question. Pressure is measured in. Okay. So almost all students given answer of first question correctly. Pressure is defined as force per unit area, and the pressure is measured in Newton per meter square, because we know Newton is the unit of force and meter square is the unit of area. And according to the definition, pressure is defined as force per unit area. So Newton per meter square is the unit of pressure. It is correct. So first option is correct. Then Newton per meter square is nothing but a Pascal. So second option is again correct. Then third one, higher unit. In some of the devices like pressure vessels, the pressure value is very high. So if you express that pressure in Newton per meter square or Pascal, the value will be very large. So it is difficult to read. So pressure is expressed in bar. And again, if you recall our discussion in previous session, again in that slide, again a unit of pressure is expressed given as a bar. So 1 bar is equal to 10 raised to 5 Newton per meter square or Pascal. Okay. So the correct answer is pressure is measured in Newton per meter square, Pascal, bar. So all of above is the correct answer. Okay. So again, once again, I would like to congratulate all the students. And again, remaining student, please understand, pressure is measured in Newton per meter square, Pascal, or it may be in bar, or even in some cases, the pressure is expressed in kilopascal or in PSI also. Okay. So different units are used to measure the pressure. Now let's start the next part of the course. So screen is visible, students. Presentation screen is visible. Somebody please reply. Okay, okay, okay. So in the previous session, we started various gas laws, and this gas laws basically gives the relation between pressure, volume, and temperature. So in last session, we discussed about the Boyle's law. Okay, so Boyle's law gives relation between pressure and volume. When temperature is kept constant, the pressure varies inversely with the volume. Okay, so pressure is directly proportional to 1 by V, where V is volume. If you see this graph of volume versus pressure, if volume is increased, the pressure is decreasing, and vice versa. If pressure is decreasing, the volume is increasing. Okay, again you can understand the Boyle's law from this example given over the slide. If a container containing a gas is fitted with a piston, and if a pressure is applied over the piston, the gas volume will decrease. As the pressure go on increasing, the molecules of gas will come closer and the volume of gas will decrease. You can clearly understand P1 and the volume of the gas is V1. And after applying pressure, after increasing the value of pressure from P1 to P2, the volume of gas is reducing from V1 to V2. Okay. So it indicates pressure is varying inversely with the volume, and vice versa. Volume is inversely varying with the pressure. So from this Boyle's law, we get a relation between pressure and temperature. We get a relation between pressure and volume. So P is directly proportional to 1 by V, and if we introduce the constant of proportionality, we get P is equal to C by V, or we can write PV is equal to constant. So again we get an important thermodynamic process from Boyle's law, and that process is constant temperature pressure process. What is the name to the constant temperature process? Thermal process? Somebody please tell. If the temperature is kept constant, what is the name of the process? Which type of process we get by keeping the temperature constant?
Isothermal.
Absolutely correct. Very good. Okay, so we get isothermal process if we keep the temperature constant, and in isothermal process, P by V is equal to, PV is equal to constant. That is the characteristic equation of isothermal process. And the practical example of Boyle's law is the, already we discussed in previous session, soda bottle or a Pepsi bottle or a Coca-Cola bottle, cold drink bottle. So that artificial flavor, liquid flavor is having CO2 in dissolved form, and the mixture of CO2 and that artificial flavor juice is filled inside a plastic bottle. And when we open the cap of that plastic bottle, the CO2 which is dissolved in liquid juice, it will be released. And the pressure of the total mixture will decrease, and thereby the volume of that liquid juice will increase and it will come out from the bottle. Okay, so this is the practical example of Boyle's law. Now let's come to the second law, second gas law, that is Charles law. So Charles law give relation between temperature and volume. Okay, basically all these gas laws use relation between pressure, volume and temperature. So in Boyle's law, when temperature is kept constant, pressure is inversely proportional to the volume. And next law is Charles law, and according to Charles law, when pressure is kept constant, volume is directly proportional to the temperature. This is the statement of Charles law. So according to Charles law, I am repeating the statement. According to Charles law, temperature is directly proportional to volume when pressure is kept constant. Now let's come to the graphical representation of Charles law. So let's take a graph of volume against temperature. Volume on y-axis and temperature on x-axis. And if you see, when the temperature is increased, the volume will also increase. If the temperature is increased, volume will also increase, and so on. As the temperature is increasing, the volume is also increasing. And this increase in pressure and temperature is according to the Charles law. Again, if you see here, again same example, take a gas inside a container. That container is fitted with a frictionless piston, and if we start heating that gas, before starting heating the gas, suppose T1 is the temperature of the gas and V1 is the volume of the gas, and as soon as the flame is ignited, the gas will start to get a heat. It will start get it, and due to addition of heat in a gas, the molecules will start to move away from each other, and thereby there is increase in volume of the gas, and at the same time the temperature of gas will also increase, and this increase in temperature of gas is in proportionality with the volume. Okay, so whatever may be the increase in volume, there will be also increase in temperature. So this is Charles law, and a very famous and common practical example of Charles law is the hot air balloon. I hope you have at least know about the hot air balloon. So hot air balloon, its working principle is based on the Charles law. Okay, so hot air balloon mainly consists of a balloon which is attached to a basket, and through that basket we can carry or we can move from ground level up to the certain height, and as well as we can cover certain distance. Okay, and this hot air balloon is filled with air, and as soon as the burner is started, there is a burner is provided, and as soon as we ignite the burner, the heat will be added, and this heat will be taken by the air which is present in a balloon. So due to the addition of heat into the air, the molecules of air will move away from one another, and they will become lighter in weight. And again, we know hot air is lighter than the cold air, so this hot air will start to move in upward direction. So it will carry the balloon, and as the balloon is fixed with the basket, so basket is also carried along with that hot air into the atmosphere, and we can cover the required elevation as well as we can travel a certain distance through a hot air balloon. Okay, so hot air balloon, it works on Charles law. This is a real life example of Charles law. Now let's come to the third law. So far we discuss about relation between pressure and volume and temperature. Now the third important gas law is Gay-Lussac law. It gives relation between pressure and temperature when volume is kept constant. Okay, so when volume is kept constant, pressure is directly proportional to temperature. Again, let's come to this graph. This is a graph of pressure versus temperature. Okay, and again, if you see the nature of this graph, this inclined straight line, as the temperature is increased, pressure is also increasing, and it go on increasing. Okay, and to understood how this graph is plotted, one experiment is conducted. In that experiment, a hot plate is taken and a container, a barrel is filled with a liquid, and that barrel is fitted with a conical flask which is filled with a glass, and at the end of the conical flask a pressure gauge is attached, and as soon as we turn on the hot plate, heat will be added as shown in second diagram. As the heat is added, the liquid will start to get heated, and this liquid will transfer this heat to the gas, and the gas molecule, as the volume of gas is fixed, the gas is filled in a conical flask. So whatever may be the volume of the conical flask, it will be the volume of the gas. So volume of gas is fixed. So as the gas gets heated, its molecules start to move, and thereby there is again increase in pressure of the gas inside the conical flask, that you can clearly observe in diagram number 3. So volume of liquid also increases, the gas molecules will start to move with higher internal energy, and thereby they will exert a pressure on a plunger of the pressure gauge, and pressure gauge reading will increase. So this increase in pressure is according to the Gay-Lussac law of thermodynamics or gas law. So pressure is directly proportional to the temperature when volume is kept constant. I hope all these three gas laws are clear to you. Student, please ask questions.
Yes, sir.
If you have any doubt, whenever you feel that it is difficult to understand, or if you have any query or any doubt, please be free to ask the question. You can unmute yourself and ask the question anytime, or you can put the question in the chat box. Okay, we'll have a question answer session at the end of every session. Okay, so please be free to ask the question. Okay, as I told you in the first session, there are a lot of fields where you can work or you can make a career, but for making a career in a particular field, your fundamentals should be very clear, and this thermodynamics is totally a fundamental based subject. Okay, so be attentive, and whenever you find it is difficult to understand or if you have any doubt, you can unmute yourself and ask the question. Okay, so we'll continue. So I hope all these three gas laws are clear to you. Okay, so again briefly I will revise these three laws. So first law is Boyle's law. According to the Boyle's law, when temperature is kept constant, pressure varies inversely with the volume and vice versa. Second law is Charles' law, which gives relation between volume and temperature when pressure is kept constant. So volume is directly proportional to temperature. And the third gas law is Gay-Lussac law. And according to this law, when volume is kept constant, pressure is directly proportional to temperature. And the example, real life example of Gay-Lussac law is the hot versus cold tire. So you can observe this phenomenon while driving the motorcycle or car. So if you see in images, cold tire pressure is 35 psi. So if you feel a air in a tire, motorcycle tire or car tire, the pressure is generally in psi. What do you mean by psi? What is psi? You can unmute yourself. What is psi? Students, please answer.
So pressure pounds per square inch.
Absolutely correct. Very good. Pounds per square inch is the one of the unit of measuring the pressure. It is British unit, pounds per square inch. Okay. So psi, 35 psi, 30 to 35 psi is the normal range of air pressure in a tire. Okay. And the volume of air is constant in a tire. Okay, whatever may be the volume of the tire, it will be the volume of the air that we are filling inside the tire. So volume is constant. Okay, and we are filling this air into the tire at certain pressure, 30 to 35 psi, which is equivalent to something 2 to 2.5 bar. Bar is again a unit of pressure. Okay, and when you start to drive the car or a motorcycle, when the tire come in contact with the surface of the road, so there will be a friction. Okay, and this friction will generate a heat, and this heat will be taken by the air inside the tire. So what will happen to the air inside the tire during a driving condition? So as the gas molecule get heated, air molecules get heated, and the volume of gas is constant. So molecules will start to move away from each other. The distance between the molecule will increase, and this leads to increase in pressure of the air inside the tire. Okay, so as after certain time interval, if you measure the pressure of air immediately after stopping the car or a motorcycle, there will be slightly increase in the pressure of the air. Okay, so it is according to the Gay-Lussac law of thermodynamics or gas law proposed by Gay-Lussac. As soon as pressure is increased, the temperature will also increase. Okay, so you will feel that the temperature of tire is higher than the surrounding temperature. So it indicates during driving condition, the Friction, due to friction, heat energy is generated, and this heat energy is converted into internal energy. There will be increase in internal energy of the molecules of the air, and it leads to increase in pressure of the air inside the tire. So it indicates there is increase in temperature of the air as well as increase in pressure of the air, and this is nothing but a Gay-Lussac law. Okay, so when volume is kept constant, pressure is directly proportional to temperature. I hope all these gas laws are clear to you along with the real life examples. Okay, now let's come to the next part. There are different viewpoints to understand the thermodynamics. So generally two viewpoints are used for learning or understanding the thermodynamics. So first one is the microscopic, and second one is the macroscopic. As the name suggests, micro, in microscopic viewpoint. So in microscopic viewpoint, system is considered as made up of number of molecules, and each molecule is having certain velocity in all the directions, x, y, and z direction. So it will have a velocity, it will have a momentum. That molecule, as it is moving with a velocity, it will have its own kinetic energy. The molecule is placed somewhere in a space, so it is having a potential energy. Okay, so all these things are considered. When all these things are considered while learning the thermodynamics, then that viewpoint is the microscopic viewpoint. Okay, and all this will leads to the energy transfer. So this study is known as microscopic viewpoint of studying the thermodynamics, or it is also called as the statistical thermodynamics. But when we consider that system is made up of number of molecules, and we are going to analyze the thermal system for every molecule, then that analysis of that system will be very complex. Lot of mathematical equations will be generated, and the mathematical equations are the number of mathematical equations that will for every molecule there will be a mathematical equation, and as the gas is consist of or a system is consist of a number of molecules, so there will be large number of mathematical model. So it will be very difficult to analyze the particular system. That's why this microscopic viewpoint or statistical thermodynamics is having a limited application, or this viewpoint is used for very few applications, such as if you want to analyze the low pressure gases, then this approach is okay, or for substances which are at very high temperature, then we can analyze such type of applications by using a statistical thermodynamics or microscopic viewpoint. But if you see the day-to-day life thermal devices such as pressure cookers, refrigerator, motorcycles, then this viewpoint is very difficult to apply for this day-to-day life devices. So the second approach is preferred, and that approach is microscopic viewpoint, and this approach is also called as the classical thermodynamics. So in this viewpoint, studying of energy transfer and behavior of working substance is important, and the properties of a system are measured in this approach, and they are used to analyze the system, and this approach is commonly used. So onwards, whatever we are going to learn or whatever we are going to analyze by using a thermodynamics, it will be based on classical thermodynamics. So only we are going to measure the properties of the system, and on the basis of that properties we are going to analyze the different energy transfer that are taking place in a different thermal devices. Let's take example of a refrigerator. Okay, so energy transfer is taking place in a refrigerator. Electrical energy is given as an input, and this electrical energy is used to produce the desired effect. That is used to maintain temperature lower than the surrounding temperature, and thereby we are preserving the products for longer duration. And if you want to analyze the performance of the refrigerator, so we are going to use the macroscopic, or it is also called as the classical thermodynamics approach. I hope these viewpoints are clear to you. Okay, understand, micro means molecular level and macro means we are going to analyze the thermal devices by measuring the properties of the thermal device. Okay, and this classical thermodynamics approach is very common at whatever thermal analysis we are going to do here in thermodynamics, as well as all the applications of thermodynamics. It is based on classical thermodynamics or macroscopic viewpoint of learning the thermodynamics. Now, continuously we are using the word system, and onwards again we are going to use this word consistently. So, what do you mean by system? Okay. So, it is clearly mentioned over the slide. System is nothing but a quantity of matter or a region in a space chosen for study. If you take an example of pressure cooker, so pressure cooker is our system. If you take an example of refrigerator, then that total refrigerator is our system. Okay. So a quantity of matter or a region in space chosen for study is system. Okay. And anything outside the system is its surrounding. So whatever mass or energy transfer that is taking place from system, it is with surrounding. So anything around the system is surrounding, and imaginary or a real surface which is separating system from the surrounding is its boundary. If you observe this diagram carefully, you will come to know the system is a quantity of matter or region in space chosen for study. Outside the system is surrounding, which is generally atmosphere. In case of most of the thermal devices, they are directly exchanging energy with the surrounding. Take example of refrigerator, it is rejecting heat to the surrounding. Motorcycles, again they are rejecting heat directly to the surrounding. So motorcycle is a system and atmosphere is the surrounding. And a real or imaginary surface which separate system from surrounding is a boundary. Okay. So again that boundary may be fixed one or it may be movable. If you take an example of internal combustion engine, the boundary is movable. The piston head is one of the boundary of the internal combustion engine. If you want to analyze the internal combustion engine or an engine of a car or motorcycle, then that piston is movable. Means the boundary type is movable, real surface type of boundary. Okay, so boundary may be fixed type or it may be movable, it may be real or it may be a imaginary surface. Okay, so I hope you understand what is system, what is surrounding, and what is boundary. Now let's come to next part, types of systems. Okay, so systems are generally classified into two types: control mass and control volume. Control mass means the mass flow is controlled, means the mass will not move out from the boundary of the system. That type of systems are called as the control mass, or it is also called as the closed system. And control volume means the mass is continuously entering and leaving the boundaries of the system. That type of systems are called as the control volume system, or they are also called as the open system. And the third type of system is the isolated system. Okay, so we'll start with the first type of system, that is closed system, or which is also called as the control mass system. So these closed systems are called as control mass system because the mass is not leaving the system, or mass will not cross the boundary of the system. Again, just observe this diagram shown over the slide. So this diagram shows a piston cylinder arrangement. So this is a cylinder filled with certain gas, okay, and this gas inside this cylinder is our system, okay, and this is fitted with a piston. Okay, so here mass is not crossing, this gas is not leaving this container, so that's why it is an example of closed system. Okay, so no mass can cross its boundary. There is fixed amount of mass, but the energy can cross the system boundary. Energy may be added into the system, or energy may leave the system. There may be various forms of energy that we are going to learn in next sessions. So here you understand what do you mean by closed system or a control mass system. Okay, so no mass will leave the system, or it will not cross the boundary of the system. Only energy exchange takes place between system and surrounding. Okay, so this is the closed system. Example of closed system: in day-to-day life, pressure cooker is the example of closed system. Refrigerator, that is a part of need now for domestic purpose. So refrigerator is again example of a closed system. So where mass is not crossing the boundary, or it will not leave the system, or it will not enter the system, but energy transfer will take place. So please wait a minute. Let me download the attendance. So in this session, we conducted one quiz. Then we discussed the various gas laws, that is Boyle's law, Charles law, Gay-Lussac law, and then we started different viewpoint of understanding the thermodynamics, that is microscopic, or it is also called as the statistical thermodynamics, and second view is the macroscopic, or it is called as the classical thermodynamics approach. And then we learn system, what do you mean by system, surrounding and boundaries, and then types of system. So I hope this much contents are sufficient for today's lecture. So we'll continue the remaining part, that is open system, isolated system, in tomorrow's session. If you have any doubt, please ask. Student, please be free to ask the doubt. No doubts. Okay, so we'll stop here. Bye, student. Have a nice day.